Question number 57. Let M be the minimum observation in a random sample of size n from a distribution that has PDF fx equals to e to the power minus x minus theta. What is the distribution of 2n into m minus theta? Here the PDF is given as f of x equals to e to the power minus x minus theta. Now we have a random sample of size n. So each xi is actually shifted exponential distribution. That is, if we subtract theta from each xi, let's say that this is a new variable yi, then each xi minus theta is exponentially distributed with parameter 1. That is yi. Each yi is exponentially distributed with parameter 1. We can prove it using the transformation method also, but we will not do that transformation here. We can simply use the fact that xi minus theta is exponential with parameter 1. That means yi is exponential with parameter 1. Now we are given m minus theta. What is m here? M is the minimum observation. We can write that m is the minimum of x1, x2, xn. Right? Now we have to subtract theta from m. So we subtract theta both sides. Minimum of x1, x2 up to xn minus theta. Now using the properties of minimum function, we can write that minimum of we can subtract this theta from each xi. x2 minus theta up to xn minus theta. Now this x1 minus theta is exponentially distributed with parameter 1. So on the place of x1 minus theta, I can write y1. On the place of x2 minus theta, I can write y2. On the place of xi minus theta, I can write yi. So this can be written as minimum of y1, y2, yi, yn. Because from here we can write this is true for all I going from 1 to n. Do not get confused by this. We can simply write y1, y2, yn. Now each yi is exponentially distributed. We know one property of exponential distribution, that minimum of exponential distributions also follow exponential distribution. So minimum of exponential random variables also follow exponential distribution. So this m minus theta is a random variable which is distributed as exponential. And what will be the parameter? The sum of all the parameters will be the parameter of this distribution. So y1 is exponential 1, y2 is also exponential 1. So we will sum 1 plus 1 plus 1 up to n times. So the summation will be n. So this m minus theta is distributed exponentially with rate parameter n. Now we have to multiply this by 2n. If we multiply a exponential random variable with some constant, then that constant will go in the dividation of the parameter. n is the parameter and 2n will come in the dividation because we are multiplying here. If we divide by some constant, this constant will go in the multiplication of the parameter. So this is the property of exponential distribution. So this will follow exponential distribution with parameter half. So if lambda is half, then what is the mean? Mean is 1 upon lambda. The value of lambda is 1 upon 2. So mean will be 2. So this 2n into a minus theta is exponentially distributed with mean 2. This 2n into a minus theta is exponentially distributed with mean equals to 2. Option B is correct.